Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In today's video we are going to talk about temperature variations. Very simple concept. In previous videos we saw that we can define minimum and maximum temperatures for a given day or month or year, whatever we want to analyze. Let's say daily temperatures. Now we also saw that average or mean daily temperature is defined usually as the arithmetic average of these two values. How about temperature variability or variations? That is usually indicated as delta T, and it is defined as the simple difference between maximum and minimum temperatures. And this is what we are going to discuss today. Very simple concept. Temperature variations are the biggest close to the surface and further away from big bodies of water such as lakes, seas, oceans, and so on. Let's first discuss dependency of this quantity on the altitude. Because atmosphere is predominantly heated from underlying surface, as we saw in my previous videos, then further away we are from the surface, the smaller temperature variations. The atmosphere is less reactive to the source of heat. During daytime, sunshine is heating surface and surface is heating the atmosphere. During nighttime, there is no sun. The atmosphere is the surface is radiating heat. The surface is getting colder, therefore, and it is cooling the atmosphere. Well, the further away we are from these processes are less influencing the temperature. So, a simple example and very instructive example. Let's say this is the surface of the Earth, and this is height axis. We said we use Z to indicate height. Let us say we have a building, this building that has these three floors, ground floor 1 and 2. And let's put a simple table over here that will have maximum temperature, minimum temperature, and then this temperature variability, delta T, that we quantified here. And all values are in degrees Celsius. Now, if you have three thermometers over here, what are they going to measure as maximum and minimum temperature? Well, let's say that maximum temperature at the surface, ground floor, is 20 degrees Celsius. And minimum temperature is, let's say, 10 degrees Celsius. Then the difference is 20 minus 10, it will be 10. This is temperature variability for that day. But now you have to have knowledge of my previous videos to try to guess what would be value for maximum and minimum temperature at the first floor. Maximum temperature is recorded when? Well, from my video on daytime temperature variation, you know that maximum temperature is usually recorded around 3-4 p.m. local time, so during daytime. So maximum temperature, as we are moving away from the surface, will decrease because we are further away from the source of heat, which is surface. So this value might be 19. I'm just making it up. However, this is now where I would like you to pay attention. What will happen with minimum temperature? When is minimum temperature recorded? Again, from my video on nighttime temperature variations, you know that minimum temperature is usually recorded right before sunrise, during night, namely. And during night, close to the surface, we have the phenomenon quite often called temperature inversion. That means that temperature is not decreasing with height, but it is inverted. Temperature is increasing with height. Why? Well, because again, source of cooling during night is surface. So the further away you are from surface, less cooling you experience. So what will be temperature value at the first floor in terms of minimum temperature? Likely it will be actually higher than close to the surface, so the value might be 11 degrees Celsius. Now if we plug in those values in this formula, you will see 19 minus 11 is 8. Temperature variation is 8. It decreased with height. If we would go now to the second floor, ground floor, first floor, second floor, then the maximum temperature will continue decreasing, perhaps dropped for 2 degrees Celsius, I don't know, let's say 17, so we just don't go by one number. But what about minimum temperature? Well, this is now something where we can speculate. And speculate in terms of what is the depth of this inversion layer. Depth of inversion layer is usually few dozens of meters, sometimes just few meters. So let's assume that this inversion layer in which temperature increases with height is just the depth of these 2 floors. This is our assumption. That means at the third, or rather second floor, minimum temperature will probably be 10 degrees Celsius. In other words, what I'm saying here in terms of the curves, if this is the height and here is maximum temperature, then maximum temperature is decreasing with height. But in terms of minimum temperature will increase with height and then decrease with height. That's the curve for minimum temperature. So now you can see that 17 minus 10 is 7. So what we demonstrate here is that temperature variation decreases with height, and the reason is what I discussed before. A person is further away from the source of heat or the source of cooling during nighttime. How about temperature variations in terms of being further away from big bodies of water? Well, water has very high heat capacity. That means that temperature variability close to water is smaller during day, month, year, whatever the period is, than further inland. And we will provide an example and much deeper discussion of that in the next video because it's a very important phenomenon. Also, if you are in a city, then 24-hour temperature variation is usually smaller than in rural countryside because of the so-called urban heat island effect, and that again deserves entire video, which I will discuss in one of the next videos. Make sure to like and subscribe, share this video and comment. This helps channel a lot. And until next video, goodbye.